Okay, so after plotting the frequencies of the movies, he's going to do a little bit more processing here, creating an aggregate tagline text collection. So I'm not quite sure what's going on here, but still some more processing. And finally, he starts to do some things that we can recognize. So he has something called document collection. And what's he doing here? Well, we saw this before. He's using this function, strip white space, which we saw before. And his comment confirms that. And then with document collection, after he's stripped the white space out, now and saving it to the same variable, then he changes everything to lowercase again here. And then he removes the numbers. Remove numbers. We didn't have that, but I guess there's a function called remove numbers, which I'm not sure why we need to do that, but maybe we don't really want numbers when we're doing text mining, usually. They don't usually give us the right kind of information. Remove punctuation. So he does all of this kind of stuff. And the stop words here. And then he says there's more we can do in terms of data preparation, like stemming, looking for contractions, pronoun progressives, and so on, but I guess he's not going to do that. Okay, now he says we take what is clearly a bag of words approach here. The workhorse technique will be the term document matrix. Now, when you create this term document matrix that we talked about, now let me just show you that again just to remind you. So just to remind you, remember you have the documents as rows, and you have the columns are the terms. Okay? Now that kind of approach, when you create a term document matrix, that's called bag of words, right? We're just sort of making this document into just like we're just counting how many words are in each record or each row, right? We're only recording how many words are. So that's that takes a lot of the information that was originally in the data away. Like we don't have the grammar at all. We lose all of the information that's contained in the grammar. All we're doing is looking at how many words, which words are in each record or each movie tagline. Right? That's all we're getting. We lose the entire grammar, of the data, right? So we're losing tremendous amount of information, but still, it turns out that you can do interesting things that are worthwhile. Anyway, this approach of losing all the grammar and just converting it into a bunch of words is called the bag of words approach. And we're going to use the term document matrix function. So here it is. So we take our document collection and we use the term document matrix. And just to remember what it is, here it is. So you need X, and X is a corpus. So this should be, and it must be, this must be a corpus. So this document.collection that we're using here, he must have made it as a corpus. In fact, we could have known that because tmmap, I believe, needs a corpus here. So anyway, it's a corpus, and so it will create this term document matrix. And let's see, sorry. Where is it? Here. So this is called Initial Movies Term Document Matrix TDM. Okay, the next thing is, now it's a big matrix, right? It's not really the database anymore, it's just this big matrix. So now we can remove sparse terms. That was something we learned about. And then after we've done that, okay, let's try that. examine movies. Let's see that. Okay, well, when we do this, we remove the sparse terms. We still have a term document matrix, and then we're going to do this. We're going to do this, and if we check the structure of it, we see that it's a character vector, and if we check the first few terms, we have these, and it's a vector. So it says it's a vector. And now we can print that, and we see this. It's a big vector, and it has these terms. 300 terms. And we used 25% as the we said that they have to be at least in 25% of the records in order to keep that word. Okay, then he says if you look at this list, you'll see some what are called contractions. Where are they? Contractions. For example, this can't. So he wants to get rid of those. I guess that's a good idea. Especially contractions usually mean the negative of this. Anyway, he's deciding that he wants to get rid of those words. So he says, an analysis of this initial list of top terms shows a number of word contractions which we might like to drop from further analysis. Recognize them as stop words to be dropped from the document collection. So he creates the list that he wants to drop. So it can't, didn't, doesn't, don't, these words, all the way up to here. And he makes a vector, string vector, and then he says, I want to drop those words using remove words. Okay, so now we have a new document collection here. And then again, he creates a term document matrix with that new collection. So first, he's not removing it from the term document matrix. He's removing it from the entire collection. And then he again makes the term document matrix, saves it in here. Before it was called something else, examine. This is, I guess, a more final version. And save movie documents and document collections corpus. So this will save it for us to this file. No, sorry, maybe it's this file here. But actually I didn't see it anywhere. I didn't see it because I didn't run it yet, so here it is. So he saves that. Remove sparse terms. Oh, we did that already. Well, remove sparse terms now. He's doing it again. And then printing. And now we only get 200 words. Actually, I don't see just 200 words. The result of this is a bag of 200 words? I don't think so. More than 200 words. Well, I don't know. Okay. Okay, now comes a test. Does looking at taglines hold promise as a way of identifying movie trends? If it does, then years closest in time, so years that are close together in time, should be close to one another in a text measurement space as reflected, say, by multidimensional scaling. Okay, so we already talked about this when we looked at this picture, and we saw that these movies are close to each other. These movies are close to each other. This is close to each other in this measurement, which he hasn't explained yet, but and these are close to each other. So that means that his measurement is kind of accurate in some sense, because it's saying that movies that are close together in time are also close together in terms of this measurement that he's created. Therefore, this measurement that he's created might be useful. So anyway, we're going to talk about that in the next video, how to do this analysis, how to make it.